Today's lesson involves the subsets of real numbers. We're going to be working a lot with various numbers throughout your mathematical careers. So we're going to get to the point now where we need to be able to classify the numbers that we are working with in these problems. So with the subsets of real numbers, there are 6 different groups for which a particular number can be categorized. You will see that for any one given value, there may be many groups that it could be associated with, or an overlap of the groups occurs. So what you see on the slide here is what we call a Venn diagram, V-E-N-N, in case you want to look that up, showing the relationship between the groups of numbers that make up the larger group of real numbers. So as you can see, we have some smaller groups, the smallest which being the natural numbers in this Venn diagram. And the natural numbers, we call them natural because it's what's natural for you to learn first. So if you think back to your younger years, the very first numbers that you probably learned started with 1, 2, 3, and worked on up. All right, that means, in other words, because those are how you count, another name for natural numbers can also be the counting numbers. So that's sometimes a nice way for people to remember what the natural numbers are. These are the numbers we count by. Start with the number 1 and work your way up to as high as you want to count. The next subset of real numbers is the whole numbers. And the whole numbers, despite the way the Venn diagram makes it appear, is not much larger than the natural numbers. In fact, it only includes one additional value. So you may already be guessing what that additional value is. The whole numbers is when we are going to start with 0 and include all of our counting numbers as we did in the natural numbers. So for whole numbers, it's all of the natural numbers, but now we're also going to include 0 with the group. Next larger group is the integers. Start thinking about numbers we haven't included yet. Hopefully some of you are already coming to the inclusions. What about the negatives? And that's indeed what you want to consider for the integers. The integers, we're going to consider all of the whole numbers, but now we're going to go in the opposite direction as well. We are going to include the negative whole numbers, if you want to think of it that way. So we can go as small as we want negatives, we can go as large as we want positives, but so far we're only dealing with whole numbers. I'm saying this for a reason because then we get to rational numbers, and this is where everybody's favorite, fractions and decimals, occur. Now we're going to get a little specific when it comes to the decimal portion of rational numbers. If a number is considered rational, this is a decimal that either terminates, which means comes to a significant end, or we're also going to include a repeating decimal, such as 0.33333333333, which hopefully by now you know is the fraction 1/3, or 0.66666666666, that's 2/3. Okay, those are two that you should definitely try to memorize if you can. So dealing with our groups right now, you might come to the conclusion, well, we've talked about everything. Almost. We've almost talked about everything. Irrational numbers. Irrational numbers, this is a very select group. There aren't a lot of them, but we do definitely need to acknowledge that they are special in their own right. The most famous of these, the value pi. This is a decimal that doesn't repeat, but it doesn't terminate either. So this is why we have to separate it into its own separate group. Another common irrational number that you will use throughout the year, square root of 2. Okay, don't panic if you're not familiar with square roots yet. We will get there as the year goes on. Now, the biggest thing here is, so far, we've only talked about 5 groups. But in the heading, I said there were 6 groups. This entire Venn diagram, notice, is surrounded by a large light blue area. This large light blue area represents the 6th group, and that is indeed real numbers. So you should be coming to the conclusion now that pretty much everything can be included in the set of real numbers. And that's going to hold true for quite a while, right? Of course, there's always surprises later on, but we'll get to those probably when you get to Algebra 2. Okay, so let's just get a little bit of practice. Make sure that you have these copied down into your notes. You will need to identify numbers, both on homework assignments and upcoming assessments, as far as what groups they belong. So if you need to pause the video now, you can do so and make sure you have that copied down. I'm going to move on to some examples, and let's just do a little bit of practice here. Where do I belong? I'd like you to name every subset that each given value could be considered a member. And again, don't forget to include real, that 6th largest subset. So with number 1, I'm giving you the value 25. You can go piece by piece and let's see, where does 25 fit? Well, I can certainly count to 25, so I know 25 is going to be part of a natural number. Then I know the natural numbers are also within the whole number set, going by my diagram, so it's a whole number. I also know then that that is included in my integer set. Rational numbers. Rational numbers are fractions and decimals. Well, I can make the number 25 into a fraction very easily. I can put it over 1. And now that it's in the form of a fraction, I definitely know that it's rational. So 25 is a natural number, it's a whole number, it's an integer, and it's rational. Hopefully you caught that. We forgot. It's also real because everything is real. Okay, let's go to number 2. Number 2, I mentioned this in the notes in the previous slide, pi. Hopefully you remember pi is one of those really special numbers in the irrational group. And again, hopefully you are also remembering everything is real. So we've got to put that pi as a real value as well. 1/2, this should be easy for you. It's already in a fraction form, and as soon as we see fractions, we immediately want to think rational. We also want to think real, because everything is real. But now we need to check, is it a natural number? Well, we don't normally count by half, so I definitely don't want to consider it natural. Whole numbers, well, fractions aren't whole. Integer, that has to be whole numbers as well. So we're left with just rational and real for 1/2. -3, at this point, hopefully you're already filling it in. It is an integer. It is also rational because I can make it -3 over 1. And as everything else, it is real. Okay, little review with the last one. The bars around -1, what do they mean? Hopefully you're saying absolute value. Absolute value means the distance from 0. So -1 is 1 space away from 0 on the number line. So really, question 5 is asking you, where does the number 1 belong? And the number 1 is definitely a counting number or natural number. It is a whole number. It is an integer. It is rational. And it is real. Okay, so at this point, you should be able to handle the homework assignment, get a little more practice with putting numbers into their appropriate subsets. And if you have further questions, please see your teacher as soon as possible so we can get you back on track. Have a great day.